Hey, John here. Let's look at a common problem that you can run into when manipulating a container using iterators. Okay? Now for this demonstration, I create this class called foo. It is a simple constructor that takes two arguments that allows me to easily set the values of its private members down here in the constructor. Okay? I also have a friend of an insertion operator that allows it to print itself out really conveniently so that I can say cout double left and give it a foo object instance so that it'll just print itself out. All this exists for the sole purpose of making the code down here a little cleaner and easier to read, right? It allows me to do this when printing it out, okay? So what do we got here? I'm going to create a list of foo elements. I'm going to insert 7 elements, and each one of them, in the name, it'll identify which one it is, the first, the second, the third, fourth, fifth, sixth, and 7th. And the values for each one of those elements go along with it, all right? Range-based for loop, just print them all out, front to back, done, okay? Then what am I going to do? I'm going to say, give me an iterator pointing to the very first element of that list. I'm going to print that out. I'm going to say LT1 or IT1 rather, and then I'm going to say the value of an iterator, right, is star, followed by the iterator name. That represents the value of it. And because I'm inserting it here, it'll call the overloaded insertion operator, and it'll print itself out, okay? Then I'm going to say IT2 equals begin, just like I did up here. But then I'm going to advance it. I'm going to iterate it, right? I can, right? I can go forward one at a time with an iterator that references elements in a linked list. I'm going to print that one out. We should print second, right? Whatever the second element is. Well, maybe I would like to be able to advance it by 6. All right, let's go ahead and remove this comment. This won't even compile, all right? As I say over here, this won't even compile. Why? Because a list can only go forward and backward one element at a time. If you think about it, right, linked lists have these links, and you can hop forward one link at a time or backward one link at a time if it's a doubly linked list. A vector, on the other hand, inside of the vector, it has an array in there. And just like regular old C arrays, I can directly access any element anywhere, anytime I want, v sub 5, and I can give them values. So what I did here is I created a vector of 8 elements. And then I'm going to go through here and set them all to some values, right? 8 elements, they're numbered 0 through 7. Don't let that screw you up, right? Remember that. And then I'm going to say, VIT, the vector iterator number 1 equals the begin, right? So that means that this iterator, vit1, will reference the first element of my vector. It'll be that one. And unlike this, it'll be a compiler error. This will work just fine. What'll it be pointing to? It'll actually be pointing to this one right here. Okay? Why? Because begin is 0, and 0 plus 6 is 6. All right? So when I go down here to print this thing out, this should print out V6, which is 16. And when I print this one out this way, there's no special class here. These are just integers. Right? So this will directly print the 16. Now the rest of this code is commented out for now. Let's go ahead, compile it. Oh, surprise, surprise. This won't compile. All right, just to confirm, sanity check my own words there. No, you can't move around a linked list iterator wildly like this, okay? You can only do one at a time, all right? Well, let's compile it again, and it's happy. Okay, so let's go ahead and run this program. All right, what is it going to do? It prints out the 7 elements. That's great. And it prints out the first one. And then remember that IT2 was equal to begin, and then we advanced it 1 forwards, right? So here's the first element. Here's the second element. So we advance this iterator, and then we printed out its value. And that works out perfectly. It's exactly what you would expect. Vit1 printed out the 16, again, just as we expected. So let's go back up here and look real quick. Right? Remember, this one equals begin, and then we advanced it 6, referencing this element number 6 here. The 7th total right, a position. If this is the first one, this is the seventh one, which is number 6, and its value was 16, and that was what was printed out down here. Okay? Now, let's look at the stuff that's commented out. We found anomaly number 1. Iterators on one kind of container don't necessarily have all the kind of behavioral support that they do on other kinds of containers. All right, so some iterators are just different than other ones. And in the case in the linked list versus the vector, it's obvious why, right? It's hard to move those things around, okay? So they give you a utility function. Let's just add one more little piece of code here. Let's look at iterator number 3. We go to begin. Well, instead of saying, IT3 plus equals 4, we can call this standard advance utility function. Say, please advance this iterator 4 places. And because the beginning is the first one, if I advance it 4 times, it'll end up pointing at the 5th one. So if I print this thing out, we should see the 5th one come out. And that's exactly what happens down here. Right after we see the 16 that we saw before, up here, you now see that LT3 points where we expect it to, right? Because that's the first one plus 4. 1, 2, 3, 4. This being, of course, all the elements in the linked lists in the order from front to back, right? All right, so we can just call advance, in other words. Now, well, that's all ducky, but what happens if we advance too far? Okay, right? What happens here? Right? We know there's 5 elements in there, so this is okay. We didn't even check anything. We didn't even think about it. I mean, duh, right? But let's say we have iterator number 4 and we go to begin. We say iterate forward, 999 times. Well, clearly there's only 7 items in our linked list. Now, what's going to happen when this one runs? Okay. Well, you can go look at the doc for advance, but what's going to happen is it's going to run into end and then just stay there. Okay. It'll try to iterate forward. It'll run into the end. And when it comes back, advance will say, I hit the end. So if we ask if it's not equal to end, then it means that this advance worked and it moved it forward that many times. And therefore, I'm going to print out something. In other words, IT4 is a valid iterator. If it moves to end, I cannot dereference the end. Otherwise, my program will die. Even if it prints something, it's wrong. It will be non-portable and very inconsistent and have undefined behavior and most likely die at awkward times if you try and use things that have become invalidated. So I'm going to print out this message instead if it ends up going too far. And that's exactly what it did. So we went too far, and it came back and said, okay, IT4 is equal to end. Okay? Okay, what happens down here? What happened to iterators when inserting and deleting things in a container? This should say what happens. So what happens? Vit1 is still, remember, pointing to Vit6, or V6, I should say. And I want to delete that thing. Okay. How do I know this thing is going to become invalidated, right? Well, it's because I read the doc. If you come over here, what do we got? The cppreference.com. This is the list documentation. Here is the vector documentation. Let's come down here and see what happens when I call erase. Erase, erase, erase. Where's my erase? Here it is. We read the doc. Erases the specified elements in the container. Well, what am I doing? I'm basically calling this one. I said erase, and I give it an iterator. Erase the element at the position that's represented by the iterator. And in this case, I said erase vit1, which we already saw a minute ago, is pointing up here at v sub 6. And by definition, right, if you delete this one, the vector is going to move this one up and fill the hole. So the total number of elements here was 8, as I originally started, right? If I delete this one, the total number of elements will go down to 6, or rather 7, And it'll go 10, 11, 12, 13, 14, 15, 17 if we just printed them all out after we deleted it, right? And what then happens is the real question. To vit1, if I erase the element that vit1 references, what happens to it? It being the iterator, not the element that I erased. The element that I erased is deleted and gone. Well, what about that iterator? Okay. As we'll see, it becomes invalidated. Okay, so it says, look, it erases the thing, the elements that are specified, right? Number one, it removes the element at pause. Otherwise, we can do a range-based removal. I think we talked about range-based removals before. So there's variations in here. So these are the ones that are type 1 calls where we just pass it a single iterator, right? We're saying delete the one thing there. Okay. What does it say here? This is very important. Read this and think about it for a minute. It invalidates iterators and references at or after the point of the erase, including the end iterator. What that means is that any iterators that refer to this element here, because that's the one that I'm erasing, or any one after it, even if I saved an iterator and assigned it like v-end up here, that's no longer valid. No iterators that point to these elements or v-end are valid anymore if I erase that element right there. That's what that doc means. So if I come down here after I've erased the element at vit1, and then I naively go, okay, here we go, I'm going to print this thing out that I just erased. What does that even mean? Right? Now, you could probably reason yourself out that when an erase is done on a vector, and this element here is moved up here to fill in that hole, if it really is an array, that vit6 would probably still point at the element whose index is number 6, but the value 17 would have been moved into there, and I could print that out down here, right? I mean, you could probably reason that out. And I give it a 50-50 shot that could even happen when we run this program. But what else could happen? Well, what if, when I remove this, the vector class decides to reallocate the array inside here and change the capacity? It might actually move all these elements somewhere else in the memory of the machine. Well, now what would happen? Well, it would depend on how it implements its iterators. All right, well, it's an array, so maybe it just stores an integer in there that remembers which one element it is. I don't know. That's up to the designer of the library. The point is, it's not legal. It is an invalidated variable. It is totally illegal to do this. Well, let's do it anyway. I won't get arrested. No one's watching. So what happens here? Well, surprise, surprise. It points to 17, probably for the reason that I outlined there, right? So let's, right after the it went too far message here, we see number 17 being printed. So where's the it went too far message is right where? Right here, okay? So we printed that out, and then we saw the 17, right? We deleted v6, which said 16, and we did this, which is illegal, and we got away with it, okay? And as I mentioned here, even Valgrind may not know that this errant thing has happened. So let's go ahead, we got to run it here. Let's Valgrind it and see if it can figure that out, right? So, I mean, this can't solve every problem, right? Why can't it solve this problem? Well, it's because I'm not referring to memory that has been deleted, right? The memory of that vector, the array inside the vector, is still in use. And when I refer to it, and this is purely due to the way this particular version of the standard template library has been implemented, just because I can still see something and I can make sense of it does not mean it's okay, all right? So this is just wrong, and even Valgrind can't help you. These kind of problems in real systems are really a pain in the butt to fix, all right? Because what happens is they will fail at weird times. You know, all of a sudden there'll be, oh, we've upgraded our libraries, and all your programs start failing. Right? Because they changed how it works. And it was never legal to begin with. You know, you got lucky in the past, and all of a sudden you ain't get lucky no more. This happens over the course of time when you maintain your code, if you update your libraries. It also will happen if you try to move it to another kind of a machine, right? And maybe it'll work on a Mac, and it won't work on a Linux, but it will work on, you know, something else, and it won't work on Windows, and that's just a pain in the butt, all right? So don't just guess your way through stuff and just say, well, you know, it did the thing that I thought it was going to do. No, 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 no. It's illegal. Don't do it. Okay? All right, so let's see what's going on down here. All right? Let's just change this to if1. And when we get down here, IT1 is still pointing to the first element of the list, right? We haven't moved IT1. We did move IT2. It's now pointing to the second element, right? Because it started out by pointing to the first one up here. Where is it? It was before the vector shenanigans, right? We point to the first one, and then we advanced it to the second one, and we printed it out right there, okay? Point is, that's a true statement. IT3 is still pointing to the fifth element. Remember, that was the one that we advanced using the advance function right here, okay? When we printed this out, it said, oh, I'm at the fifth, right? Because the first one is the first. You add 4 to that, you end up with 5, okay? Or the fifth, rather. Okay, now this one over here, IT4, is still pointing to the end of the list, right? Is that true? Point to the beginning. Oh, yeah, right? Because we advanced it to death and ran it in off to the end of the list. Okay, so this is the state of these iterators at this time in our little test program. What happens if I erase an element by using IT2, right? ID2 becomes invalid, but the other iterators will still be okay. Right? Is that the same as a vector or not? No, it is not. When I did erase on a vector, that's the rule. Any and all references that point to the thing that was being erased, as well as any iterators and references that point after the thing that that is being erased, are all invalidated in a vector. Let's look and see what the rule is for the list, right? If you don't know, look it up. You will screw up. There'll be weird behavior. Sometimes things will work, sometimes they won't. Things will fail. Honestly, in my life, I can't stand it when my programs die. Once I write something, I give it to a customer, I never want to see it again. I don't get married to my code. Oh, it's my little baby and I want to fix it forever. No, boring. I never want to see it again. I never want to get called at 4 a.m. I never, ever, ever want to fix my own garbage, okay? Move on. I want to do new things all the time, not old things over and over again. What's the point, right? Yeesh. All right, I digress. What do we got here? Erases the specified element of the container. It looks a lot like the last one. You got a position. You can give it an open-ended range, okay? References and iterators to be erased are invalidated. Other references and iterators are not affected. The wording here is different. Only those iterators and references to the erased elements will be invalidated on a list. The vector erase, right? Here's the vector, stupid menu, right? This one says at or after the point of the erase. including the end iterator, are all invalidated on a vector. So in a way, the list is actually a little bit, it gives us more flexibility. So what happens if I delete the element that IT2 points at down here? All right, let's do the illegal thing again. All right, let's see what happens, just for fun. So the rules say I can, what? These are all still valid, and I can print out their values. I can dump out the entire list before deleting the element at LT2. That's funny. I used to have a server called LT2. I keep typing that in wrong. Iterator2 is IT2. Okay, sorry about that. What do we got? We print out the values of the foo object that each of these iterators refer to. Dump out the whole list. I erase the element in the linked list that IT2 refers to. When I dump everything out again, see what's going on. All right. This is interesting. Just like the vector, I'm going to try and access this element after it's been erased. Okay. Let's make that. Clear up my mess. And run this one. What happened? Well, I don't see any core dumps. Right, there's my it went too far. Okay, and I removed my illegal referencing that printed out the element whose value is 17 in the array. Right, so this is all old business up here. Okay, this is what I just commented into the code. I'll say before deleting IT2. IT1 was pointing to the beginning of the list. That's the first one. IT2 was pointing to the first one plus 1. It iterated forward, so that'll be the second one. IT3 was the first one plus 4. We called advance and advanced this 4 positions, so that's the fifth one, right? And we print out our whole list. We have not yet touched anything. First, second, third, fourth, fifth, sixth, seventh. They're all here. Now I call erase. I should have said erasing, but in my mind it's deleting. But we called erase to remove the element that IT2 references, right? And then we print out IT1 is the first one. IT2 is the second one. Well, that's interesting. It never went away. IT3 is the fifth one. We dump out our whole list. First, third, fourth, fifth, sixth, second. Well, we can clearly see the second one is gone. So the erasure worked. But this sure seems weird. The iterator still can be used, and I can see the old value in there. And even though it's not even in the list anymore, all right? It looks good to me. No, it isn't. And Valgrind will find this one. All right, so if you Valgrind this program, it should gripe that I'm using stuff I shouldn't be using. And yes, look at all the spew in here. All right, so what do we got happening up here? Let's go. It's very unhappy. Okay, so here I am running the thing, okay? Hello, I'm Valgrind, and I'm checking stuff. So here it prints all this stuff out, and everybody's happy. Before deleting, everybody's happy. Nothing bad, nothing illegal. Okay. Then I say, after deleting IT2, here's the node that IT1 references, and now you'll notice that Valgrind says, oh, you're doing something wrong here. Total crap. All right, remember, this is right away where it said IT2 equals, hey, I'm the second one, and I didn't really go away. Yeah, there's still probably some data, garbage, noisy data left behind, some residual residue from the second element of the old second element that had been deleted. But Valgrind noticed that it shouldn't be used anymore, right? So what is happening? I read 8 bytes. That's what that means. Read of size 8. Somebody read an 8-byte value, probably a pointer, a 64-bit machine. That was done at this line of code in the middle of some library that I didn't write. I don't know. And it was called by this insertion operator on line 22 of my program. Aha. This is me trying to print out the value of the element that was deleted, right? And this was called on line 108 in main. So this is probably me trying to print the value of the element at the LT2 reference, right? Now it says, look, the address here that I'm trying to read. It's 24 bytes inside of some block that was freed up earlier by this delete operation that was related to this stuff and these library things that I don't know anything about, that was ultimately called by line 104 in main. All right, so I tried to use the insertion operator to print it. It's the only time I use it in this program on line 108. I tried to print something that was originally allocated. It was freed up. Oh, I'm reading this thing wrong. It was freed up on line 104, just before 108. And then down here it says, oh, by the way, the thing that was deleted was originally allocated. That's what I thought I was reading, by this code over here, which is on line 34 of main. Okay? So something was allocated on line 34 of main. It was then deleted on line 104, and it was printed on line 128. So if you have no clue whatsoever, you got 34, right? There's the second one that was originally thing. What was it? Was it 54 or 58 or, oh, darn it. I am the one with no clue. 34 was allocated. It was deleted on 104, and it was printed on 108. 104 and 108. So 104 is where the thing was deleted. There's no shock there. And 108 is where the thing was actually tried to be used by the insertion operator right here to be printed. All right? So this thing is just garbage. Okay? Valgrind caught me. I was a bad boy. Okay? Using stuff after it has been erased and deleted, deconstructed, or destructed, right? So let's comment out that little error right there. Let's rerun it through Valgrind, okay, right? Because, I mean, it didn't dump core before, but Valgrind did see a problem, okay? This time we ran it through Valgrind, and Valgrind's not complaining. It does look pretty good, right? After the delete, I don't print it out here. Therefore, there's not a problem anymore. And because after that, I just iterate across whatever's left in the list. The second one is now missing, and I don't try to print it, okay, with a stale and now invalid iterator. I can still function. But let's look closely at the differences here, right? So remember that IT3 was pointing at an element that came after the one that was deleted here. That's not illegal for a linked list. It is illegal for a vector up here, right? Okay, after I've deleted the element in the vector up here, where did I do that? And I commented it right here. This is commented out right here. This is me printing out the thing after I deleted it. Okay, I try to erase it here and then print out the element that had been erased. And Valgrind couldn't even catch that, but it was illegal and I shouldn't do it. Down here, I did the same kind of thing and I tried to print it out down here. Now Valgrind did catch it. Thank you very much, Mr. Valgrind. But even so, I have iterators pointing before and after the thing deleted, and this is no longer illegal. And of course, it works fine, right? As IT3 still pointed to the fifth element even after I deleted that second one. In other words, it didn't like move everything up somehow miraculously, right? Because this still points at the fifth one, right? And that all kind of makes sense because most likely iterators that deal with linked lists are most likely actual pointers to blocks of memory. And because you remove nodes out of a linked list and then you relink the list, you leave all the nodes where they were before. Therefore, all those iterators that are probably just pointers inside of them still point to all those elements, all right? So that makes fine sense, and it is perfectly legal. This is the one for the vector, right? This is the one for the list, okay? All other ones are okay. Because the guys that designed the list here knew perfectly well that this would be implemented using pointers, and therefore all the other references would remain okay. All right, so they've made that part of the formal spec. Okay, all right, so don't touch stuff after you've deleted it is the moral of the story. And the weird thing is this iterator stuff, okay? you know darn well not to use a pointer after you've deleted the object that you're pointing at, okay? But it can get a little bit more messy if you have these iterators that were around before, and then you deleted something that you weren't pointing at, and then you use them again later. You got to remember the rules here, okay? So what's the difference between the list 1 and this list 2? All right, what did I do? I added this isOdd function. All right? Now, this is an example of how this thing can manifest itself in an annoying manner. And what do you need to do about it? Same everything up here, but I added an accessor function that says, okay, is the value here odd? And that's just value mod 2. If that's not 0, then the value's odd. Otherwise, we're same down here, fill it with 7 items, print it out. Let's say I write a program and I want to delete all the odd values. Yes, I know there's a fancy way to do this that won't have the problems I'm going to point out here. But before we get there, let's walk before we run. Let's say I write a nice little naive loop here. Go through all these elements from the beginning, while not equal to end. I'm going to say, okay, I'm going to check this guy. And I'm going to say, if it's odd, erase it. If it's not odd, I don't do anything at all. I just go to the next one, okay? This is why it's a problem. What if I want to go through this list and touch it and modify it while I'm going through this list? First of all, this is a linked list, all right? It's not a vector. Every container is going to have different rules, okay? Maps and sets, you got to look at the rules for what it means if I delete an element or if I insert one, right? What happens to the other iterators? Are they still okay afterwards or not? You got to read the rules, all right? So what happens in a linked list? Well, we know darn well what happens in a linked list. You shouldn't do this. This iterator is not valid if I erase the element that it refers to. All right, we just saw what happens if we dereference this iterator after we've erased something from it. Well, what happens if we try to advance it? Okay? Is that okay? I say no. Why? Because this will ruin everything. So let's assume this is all going to be done and it works okay. Afterwards, I'm going to say, okay, I deleted all the odd ones and I want to print out my whole list again. All right, so what's going to happen in here? Okay? It's going to die. It's going to die on the first one because the very first element in the list is an odd number. So what do we do about this? Let's say I want to make this work, all right? There's other reasons why you might have to actually do something like this. Sometimes you need to go through and delete elements one at a time or something like that due to very complex reasons that are not so easy to do using a simple comparator and something like erase if, or even if the container has such a method in it, right? Because if you look down here, there's like erase, and then there's remove if, I meant to say. And this is the short cut thing that I was talking about before. And it kind of solves this problem, all right? Now, before we get there, let's make sure we understand the problem and how to fix it without fancy code, right? So what do? Well, we dumped core. Let's make sure that we dumped it in the way that we understand. We can catch this one easily with valgrind because it's going to say you're not supposed to be using stuff that you no longer have. Okay, so here's me dumping out the list, and then I say, okay, I'm going to delete the odd values. Here's the first one I'm checking. Clearly that's odd. It wants to delete it. So it's going to come along in here. We're going to do the same kind of an error. Right? Invalid read on line 58, which is in a block that was originally freed by something on line 56. Okay. And then it was originally allocated on line 36. So we got 36, 56, 58, right? 36, that's where it came from. 56, that's where it was erased. 58 is where I'm using it, and I'm not supposed to use it anymore. So what should I do? Well, if you really want to go through a list like this and erase these things while you're iterating, and it's a linked list, just do something like this. What are we going to do here? Oops. if I can use my editor correctly, what you want to do is advance it before you erase the thing, all right? All right, so we're going to say if I'm not going to wreck everything, go on the usual thing down here, okay? But if I am going to wreck everything, do something like this. Auto, P equals IT1, all right? And then, so what we're doing is saving it, right? Then I can say plus P. Right now, P points to the, what is this thing? It says P equals element after the one to be erased, right? These comments are no longer valid because I'm fixing it. Well, that's one's still okay. So what is going on here? I remember where I am now. I move to the next one. Delete this thing. IT1 is no longer valid at all. It's worthless. But I can say IT1 now equals P and fix it. Now IT1 equals the element that comes after the one that it was that I just erased. Okay? And I advance this reference, this iterator, before I erase the thing that it refers to. Okay? Now, just because I have two separate iterators pointing at, if I say erase IT1 and I saved IT1 and P up here, keep it in mind, I didn't wreck IT1 by calling erase. I wrecked the element that IT1 refers to. So what I'm getting at there is don't think that you can do something like this, all right? Right? You can't do that, all right? It's too late because it's not the iterator that counts. It's the thing that the iterator refers to. You have to advance it up here before you erase the element that both P and IT1 would otherwise refer to in the second broken example there, all right? And again, if there's nothing no shenanigans at all, you can just go ahead and move to the next one and go around. Okay, so this should fix the problem. Let's go ahead and run it. Woohoo! After I deleted all the odd ones, these are even. Did I get all the right ones? Well, that one's gone. Well, it'll be easier to just say which ones are even. So that's second, fourth, and sixth. That should be the only ones in there. Second, fourth, and sixth. So this one worked perfectly, right? Well, did it really work perfectly? Let's make sure. Right? I don't know. Let's make sure I didn't do anything else foolish. All right? Valgrind runs. Valgrind didn't say anything wrong. Okay? Is it right? It's probably right. We didn't break any rules. But just, again, Valgrind can't catch every single possible problem. But this one, yeah, it can catch this one. All right? So what's the takeaway here? Some iterators become invalid after you delete the element that the iterator refers to. In fact, I think all iterators become invalid after that. Where the vector is concerned, iterators that even point after to elements later in the container after the ones that have been deleted, erased, I should say, become invalid as well. Okay? In a linked list, all iterators are valid all the time unless you delete the element that one of them is pointing at, right? So you can't use any elements in a linked list after they've been erased. Okay, it's as simple as that. No matter how many iterators may refer to them, okay, all of them become invalid. Read the rules and always know what happens, okay? Don't just assume, okay, because this is subtle, right? Be very careful if you're going to try and use these things after you've been editing the container, right? If you don't remember anything at all, then don't use any iterators after you've deleted or added elements, okay? Just go back and start from the beginning if you have to, okay? But, the rules are pretty easy to follow. Just check them, all right? So, thanks for watching. See you later.